Hello students, let us discuss the distribution of electrons in the different orbits. Before discussing the distribution of electron, let us recall the points which we have learnt in Bohr's model. That is, an atom has a positively charged nucleus at the center and the most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in a special orbits which is called as discrete orbits. Orbits can be named as shells, energy levels. These orbits are called as shells or energy levels, which is represented by letters K, L, M, N, which is numbered as n equal to 1, n equal to 2, n equal to 3, n equal to 4, etc. While revolving in the discrete orbits, the electrons do not radiate energy. So these are the important points in the Bohr's model of an atom. Now let us discuss how the electrons are arranged or distributed in different orbits. These orbits are named as K, L, M, N, which is also numbered as n equal to 1, n equal to 2, n equal to 3, n equal to 4 respectively. So while filling the electron, that is during the making of an atomic structure, how the electrons are to be filled. So the maximum number of electrons in each shell can be determined by formula, that is 2n square. The formula, according to this formula, we can find out the maximum number of electrons that can be accommodated in each orbits. Listen here, orbits, shells, energy levels are the same word relate here. So first of all, let us find out for the first shell, that is K shell. When we use this formula for K, that is 2n square formula, that is 2 into 1 square is equal to 2. Therefore, in the first shell, the maximum number of electron can be accommodated is equal to 2. For L, 2 into 2 square, that is equal to 8. That means the maximum number of electron that can be accommodated in the second shell, that is the L shell, is equal to 8. For M shell, that is 2 into 3 square is equal to 18. That is the maximum number of electron can be accommodated in the M shell is equal to 18. Similarly, when we find for N shell, that is equal to 32. So that means the maximum number of electron which can be accommodated in the first shell, that is the first shell which here, that is the K shell, is equal to 2. That means maximum 2 can be accommodated in the first shell. In the second shell, 8. Then the third shell, 18. In the N shell, that is 32. So better we will be writing this like this. First shell, 2. Second shell, 8. Third shell, 18. And the fourth shell, 32. So this formula we are applying to find out the maximum number of electron which can be accommodated in the different shells. The maximum number of electrons that can accommodate in the outermost orbit is 8. So that is a point which is given. The maximum electron can be accommodated in the outermost orbits is 8. So that is actually leads to the octet rule that we'll be discussing. Here, then electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise. That means when we are filling the electrons, when we are making the atomic structure, first after the filling of a first orbit completely, then only need to fill the second. After filling of second only, we need to fill the third, and then afterward fourth. That means electrons are filled in the shell stepwise. Stepwise means that is electrons are not accommodated in the given shell unless the inner shells are filled. That means only after filling of first completely, then only the filling of second shell takes place. And after the filling of second only, then only the filling of third shells takes place. So these are the three important points which we need to remember while making the atomic structure. So let us take some examples like hydrogen. In hydrogen, since there is only one electron and that electron will be in the first shell, so we need not to make the other shells here like L, M, we are not making, because here there is only single electron that will be in the first shell. What about helium? Helium have two electrons. So this electron will be, both will be in the first shell. But when we take about lithium, in lithium 3 electrons are there. 3 electron means in the first shell maximum 2 can be accommodated, that we have already discussed. So 2 electrons should be in the first shell. So where we need to make the third should be make in the another shell or the orbit. So that point we need to remember here, that is in the first shell maximum 2 electron can be accommodated. So if it is have more than 2, that is maximum 2 electron can be accommodated. If it is have more than 2, then the third electron should be made in the next shell, that is the L shell. We have to make the third electron. So let us take another example. In sodium, total 11 electrons are there. So let us make the atomic structure for it. Make first shell with maximum 2 electron, second shell with maximum 8 electron. So that means 2 electron in the first shell we have made and 8 electron we have made in the second shell, that is equal to 10 electrons. So we have filled 10 electron. Since it have max 11 electron in it, so how much is remaining? That is 1 electron is still remaining. So we'll be making the one more electron, but in the second shell maximum 8 can be accommodated. So where will be making the last electron? It should be in the third shell. Now this is called the outermost shell for the sodium atom. That is, the third shell is the outermost shell in which have a single electron. So that is the concept of outermost shell. Let us make the atomic structure for an atom which have total number of electron 14. In order to make the atomic structure, first you need to make the nucleus. Nucleus, make little bit bigger. Make the first shell with making a ring and fill the 2 electrons in this way, that is 1 and 2. Maximum 2 can be accommodated in the first shell. Then make the second shell in this, maximum 8 electron can be accommodated, that is shown here 1, 2, 3, 4, 5, 6, 7, 8. That is the 8 electrons. Now still how much is remaining? 2 plus 8, that is 10 is over, but total 14 are there. So 4 electrons are still remaining that we need to make. Can we make it in the same one? Can we make the other 4 electrons here? No, because in the second shell maximum 8. So where we make the other 4 electrons? That should be in the next shell. So the other 4 electrons are made here. So this is a way of making the atomic structure. When the total number of electron is given, you have to make the atomic structure in this method. In the textbook, atomic structure for first 18 element is shown here. So all of you practice these from 1 to 18 structures you practice in the notebook. So without looking into the textbook, you can easily make once you have learned the points which we have discussed here. So that is the electronic distribution in an atom. So in this video, we discussed how the electrons are distributed in the different shells. So this is very important to make the atomic structure in order to discuss the further studies. So have a nice day.